Welcome everyone to week 1 of the course. We have prepared several videos for you this week. We are going to be introducing foundational concepts, including background information on greenhouse gases, the energy system, and the energy transition. So now, on to part 1. In this video, we explore the current state of the world, how greenhouse gas emissions have arrived to where they are today. What we'll see here is a development of CO2 emissions from fossil fuel combustion. You see significant growth starting from the middle of the 19th century with the beginning of the Industrial Revolution, which was powered by fossil fuels. This growth started to accelerate further after World War II and has now reached roughly 37 gigatons per year. In recent years, there is a slight tendency to level off. This graph concerns the breakdown of CO2 emissions by source over the past 30 years. The primary source of these emissions is the combustion of fossil fuels, coal, oil products, and natural gas. These emissions are classified under the energy sector in this graph. These emissions remain by far the most important source of CO2, which is why they will be the focus of this course. Fossil fuels, however, are not the only source of CO2 emissions. There are other sources. Industrial processes. These emissions are mainly from the cement industry. And land use change, whereby natural carbon sinks are removed and emitted to the atmosphere. The most important form of land use change is deforestation. Energy-related greenhouse gas emissions are unevenly distributed across the world. What we see in this picture is how much industrialized, denoted as OECD, countries and developing, denoted as non-OECD, countries contribute to energy-related emissions. Throughout history, the contributions of industrialized countries and regions such as Europe, North America, Japan and Australia have dominated energy-related emissions. As recently as 1990, these industrialized countries were responsible for more than half of global emissions. In recent years, however, this has changed. The contributions of developing countries has grown. This recent development should not hide the fact that there still is a large inequality in CO2 emissions. In this graph, we show the development of CO2 emissions per capita. We can see that the industrialized regions still have the highest rates of CO2 emissions per head. North America is particularly high, followed by Europe. However, both are experiencing a downward trend. Then in the middle we see Asia, and then South America, and finally Africa. Note that there is substantial variation within each of these regions as well. The next important point to grasp is the fact that CO2 is not the only greenhouse gas. There are quite a few others. The second most important greenhouse gas is methane, as you see in this picture. It is converted into CO equivalent units for ease of comparison. Later on, we will discuss how this conversion is done. Another greenhouse gas is nitrous oxide, N2O. You can see its contribution is also significant. Finally, we should mention several fluorinated gases, often called F gases. We will now dive a little bit deeper into these other non-CO2 greenhouse gases. Methane is a fairly simple compound and is the most important component of natural gas. Methane emissions come from a variety of sources, including agriculture, in which the emissions by ruminants is the most important. Next to that, there are emissions from landfills and from the fossil fuel industry, from the winning and treatment of oil, natural gas and coal. Just as CO2 and methane, also nitrous oxide occurs naturally, but its presence in the atmosphere is increased due to human activities. The main source of nitrous oxide emissions is in agriculture, e.g. related to the use of fertilizers. Next to that, combustion emissions and some processes in the chemical industry also play a role. And finally, the fluorinated gases. These are completely artificial compounds. They do not occur in nature. In contrast to the gases discussed before, hydrofluorocarbons occur in consumer products like cooling equipment and insulation foams, but also specific industrial processes like aluminium and magnesium production lead to the emission of fluorinated compounds. The emission of greenhouse gas leads to an increase in their concentration in the atmosphere. In this graph, we see what has happened to the concentration of atmospheric CO2 over time. We see that compared to pre-industrial levels, say 2 centuries ago, the concentration of CO2 in the atmosphere has increased by about 50% and is now approaching 420 parts per million. This means that for every million molecules in the atmosphere, there are 420 CO2 molecules. This may seem like a modest amount, but this increase is already severely impacting the climate. Everything is emitting radiation. The Earth mainly emits radiation in the infrared. The increased presence of greenhouse gas emissions leads to a higher fraction of this infrared radiation being trapped in the atmosphere and partly being re-radiated to the surface of the Earth. As a result, the naturally occurring greenhouse effect is enhanced, leading to higher temperatures. We already see that there is an increase in temperature of over 1 degree C compared to pre-industrial levels. This graph provides a clear picture of the temperature change. The line shows the average global temperature anomaly relative to the 1850 to 1880 average. As you can see, this temperature anomaly has been growing considerably over the last 100 years. In summary then, this first video has provided some background on the historical development of greenhouse gas emissions and insights into how we got to where we are today. In the next few videos, we will be exploring the question of where to go from here.